Step 2 in the associative mechanism is definitely going to be fast. The 7-coordinate intermediate right there is going to be very unstable. So it's going to want to pop off a ligand, and you would say, well, it could be the X or one of the 6 L's. We're going to say that it's one of the 6 L's and form the coordination compound desired. Once again, step 1 is the rate determining step. The rate law for this reaction, the rate is equal to the change in ml6 over the change in time, which is equal to the rate constant times the concentration of ml6 times the concentration of X. So the rate law for the associative mechanism is different. If you can measure the rate law and determine the dependence upon the incoming ligand on the rate of the reaction, then you can determine whether it's an associative mechanism or a dissociative mechanism. However, differentiating between the two types of mechanisms can be very difficult. There are two complications that arise. First, the two mechanisms are very simple. The actual mechanism for a reaction may be much more complicated. Second, experimental conditions may hide the dependence on the concentration of the incoming ligand. If the order with respect, or if you have a reaction where it's difficult to tell how the concentration of the incoming ligand affects the rate of the reaction, then it can be difficult to determine which mechanism is correct. So this brings into the idea of another mechanism type, which talks about concerted changes. For the dissociative mechanism, it is unrealistic to believe that the ML bond breaks, leaving a long-lived 5-coordinate intermediate. The same goes for the associative mechanism. It's difficult to believe that a 7-coordinate compound could exist for a long time. They're very rare. So a third mechanism has been proposed called the interchange mechanism, and it explains this observation. In the interchange mechanism, the ligand that's coming in, X, forms a bond at the same time that one of the ML bonds breaks. This leaves no 5 or 7-coordinate intermediate, and it could not be isolated, or these intermediates could not be isolated according to this mechanism. When talking about the interchange mechanism, you might have a tendency to say, yeah, the interchange mechanism's the easiest, it makes the most sense. And if you don't observe a 5 or 7 coordinate intermediate, then it has to be interchange. Not necessarily. The ideas of associative and dissociative are still very important. And actually there are 2 related subtypes of interchange mechanism. The first is the interchange dissociative mechanism, where the interchange mechanism is favored by the breaking of the ML bond. The interchange associative mechanism is where forming an MX bond is energetically favored over breaking the ML bond.